Good morning, children. Hope you all are safe. Welcome to the second session of Exponents and Powers. Last class, we have learned about exponents, both positive exponents and negative exponents. Also, you have learned about the laws of exponents in class 7. Let us recall those laws of exponents with a song.
Laws of exponents go like this, go like this, go like this. The laws of exponents go like this all day long. When adding like bases, you combine like terms, combine like terms, combine like terms. When adding like bases, you combine like terms all day long. When multiplying like bases, you add the exponents, add the exponents, add the exponents. When multiplying like bases, you add the exponents all day long. When dividing like bases, you subtract the exponents, subtract the exponents, subtract the exponents. When dividing like bases, you subtract the exponents all day long. With a power to a power, you multiply exponents, multiply exponents, multiply exponents. With a power to a power, you multiply exponents all day long. With a negative power, make it positive and positive and positive and. With a negative power, make it positive and move it up or down. Any base with zero power is equal to 1, equal to 1, equal to 1. Any base with zero power is equal to 1 all day long. And now you know the laws of exponents, laws of exponents, laws of exponents. And now you know the laws of exponents, and you're ready for the test. Laws of exponents.
Now, let us see which were those laws of exponents. The first law is a raised to m into a raised to n equals a raised to m plus n. So here we have seen that we have to multiply two numbers. What we do is we'll add the exponents. Now, the second law is regarding division of the exponents. In that case, we subtract the exponents. That is, a raised to m divided by a raised to n equals a raised to m minus n. Third law, a raised to m, the whole raised to n. And that is equal to the product of m and n. So it can be written as a raised to mn. Now, when the bases are different, that is a and b with the same power n, It is same as a to the power n and b to the power n. Let's have the fifth law, that is a by b the whole raised to n equals a raised to n by b raised to n. As we have learned in the last class, a by b the whole raised to negative n. It is same as b by a the whole raised to n. Now we have the seventh one, that is a raised to minus n by b raised to minus m. So that is same as b raised to m by a raised to n. Here the examples are also shown. Now as you know, here a and b are non-zero integers and m and n are integers. That's the condition for these laws of exponents. Let us solve using the laws of exponents. The given following question you have to simplify and write in the exponential form. First question, 2 raised to 3 into 2 raised to 2. Here the base remains the same and the exponents are different. We use the first law. So 2 raised to 3 into 2 raised to 2 is equal to 2 raised to 3 plus 2. So that gives the answer 2 raised to 5. Second question is 5 raised to 2 into 5 raised to 4. So that is equal to 5 raised to 2 plus 4, which is equal to 5 raised to 6. Now third one, a raised to 3 into a raised to 5. We have to add the exponents. Here also the bases are the same. So a raised to 3 plus 5, that's equal to a raised to 8. Fourth one, 4 raised to 3 into 4 raised to minus 2. As you see, here the base is the same, the power is the different. So here also we can use the first law. So that's equal to 4 raised to 3 plus minus 2, which gives you 4 raised to 1, which is same as 4. Fifth question, 3 raised to minus 2 into 3 raised to minus 5. So that's equal to 3 raised to minus 2 plus minus 5. That's equal to 3 raised to minus 7. Sixth one, x raised to 3 into x raised to minus 5 into x raised to 4. Here all the base is x and we add all the exponents. So that is equal to 3 plus minus 5 plus 4, which is equal to x raised to 2. Now seventh question, 2 raised to 7 divided by 2 raised to 5. That's equal to 2 raised to 7 minus 5. Here we are applying the second law. When division comes, we have to subtract the exponents. So the answer is 2 raised to 2. Eighth question, 3 raised to 2 divided by 3 raised to minus 3. That is also the application of second law. So 3 raised to 2 minus minus 3 comes. So that's equal to 3 raised to 2 plus 3, which is equal to 3 raised to 5 comes. Next one, ninth question, 8 raised to 7 by 8 raised to 5. Here also the base are the same, that is 8, but the exponents are different. And we have to divide. So dividing in the exponential form means we have to subtract. So that's equal to 8 raised to 7 minus 5. That's equal to 8 raised to 2. Now 10th one, x raised to 3, y raised to 4 by x raised to 2, y raised to 7. Here as you see there are two variables x and y. So we go for x and y separately. As it is division, we will subtract the exponents. So the answer is x raised to 3 minus 2 into y raised to 4 minus 7. That's equal to x into y raised to minus 3. Now 11th one, m raised to 5 divided by m raised to 2 into m raised to 3. Here as you see all the bases are the same, but here we have division and multiplication. So first we'll see with division. So m raised to 5 divided by m raised to 2 is m raised to 3. And that answer we multiply with the one more m raised to 3. So the final answer comes as m raised to 6. Now 12th one, 4 raised to 4 into 4 raised to 2 divided by 4 raised to 7. Here also there is multiplication and division. As we compare, all the bases remains the same. So first let us divide, that is 4 raised to 2 divided by 4 raised to 7. So that gives us the answer 4 raised to 2 minus 7, which is equal to 4 raised to minus 5. Then we have to combine with the first term, that is 4 raised to 4 into 4 raised to minus 5. So that will be equal to 4 raised to minus 1. Now next we can see question number 13. That is a raised to 2 into a raised to 3 divided by a raised to 5. Here a raised to 2 into a raised to 3 gives us a raised to 5. So actually the question is a raised to 5 divided by a raised to 5. That is equal to a raised to 5 minus 5, which is equal to a raised to 0. And we know using the laws, any number raised to the power 0, its value is 1. Question number 14. P raised to 8 by P raised to 2 into P raised to minus 3 into P raised to 6. So let us do it. It gives like this. In the numerator, we have p raised to 8. And in the denominator, first we will combine all with the base p together. That is p raised to 2 plus minus 3 plus 6 comes. Okay. So simplifying the denominator, it is will be 2 plus minus 3 plus 6. So in the denominator, we will be getting p raised to 5. Now the given expression is changed as p raised to 8 by p raised to 5. That's equal to p raised to 8 minus 5, which is equal to p raised to 3. Now we move on to question number 15. X raised to 5, y raised to minus 4, z raised to 5 by x raised to 7, y raised to 2, z. Here we have three different variables x, y and z. And also the exponents are different. So we group the same variables together and apply the law. So x raised to 5 minus 7. That is x raised to minus 2 comes. Then y raised to minus 4 minus 2. That is equal to y raised to minus 6 comes. Z raised to 5 minus 1. That is z raised to 4 comes. Last question, 16th one. A raised to 5, B raised to 4, C raised to minus 2 by A raised to minus 2, B raised to minus 1, C raised to 5. Here also, as we did for the 15th question, there are three different variables A, B and C. We group with the same basis and do the calculation for them. So that will be A raised to 5 plus 2. That is A raised to 7 comes. B raised to 4 plus 1. That's B raised to 5 comes. Then C raised to minus 2 minus 5. C raised to minus 7. Now the answers are given here. You can compare your answers with this one. Okay. Practice this question again and again so that you will be thorough how to do such questions. Okay. Now, let us move on to yet another application of this exponents. Usually, very large numbers are difficult to read and understand. So, what we do is we will express them as an exponent. So, that makes the things easier for us. We call it as the scientific notation, okay? Or we can call it as the standard form. So in the standard form, what we do is, however big the number is, we express it with one number before the decimal and a power of 10. So let us see how it has been done here. The given number, it can be very small, or the given number, it can be very big also. In both the cases, we can express it as the power of 10. So let us see the first question. That is 52314. Actually, it is 52,314. As I told you, we have to get just one number just before the decimal. So that means we have to move left 4 places. Okay, move 4 places. We have to move 4 places. So the given number, it is changed as 5.2314 into 10 raised to 4. Now let's have a look at the second question. 3.2. As you see here, before the decimal, there is just one number. So it's already in the standard form. We can just place 10 raised to 0 with that, so that it can be rewritten as 3.2 into 10 raised to 0. Have a look at the third question. It is 0 point followed by 4 zeros, then 4 to 8. As I told you, the thing which we have to keep it in the mind is, we have to get just one number before the decimal. So it comes as 4.28 into 10 raised to minus 5. Here we are moving in the opposite direction, so that the exponential power, when you see, it is minus 5. Next question, let's have a look. It is 602 followed by 6 zeros. Indeed, a big number. Here, as you see, it's a positive exponent will come. And as I told you, before decimal, there should be just one place. Okay. So that means we have to move 8 places. Finally, we get it in the standard form as 6.02 into 10 raised to 8. Now, given the number, in the other way also, we can change it. Okay, we call it as the usual form, or decimal notation, we call it as. So how to convert the given numbers if it is in the exponential form to usual form? First, we will see whether the exponent is negative or positive. Okay, so as you see in the first question, it is 3.52 into 10 raised to minus 5. Then its exponent is negative. We have to move the decimal point 5 places. Okay, so that already one decimal is there. We place 4 more zeros. So 3.52 into 10 raised to the power of minus 5 is same as 0 point followed with 4 zeros and 352. Let's see question B. It is 4.6 into 10 raised to 4. The exponent given here is positive. You have to move the decimal point to the right by 4 places. So it is changed as 4.6 followed by 3 zeros. Question C. 9 into 10 raised to minus 12. You see, what about the exponent here? Here it is negative. You have to move the decimal point to the left 12 places. So the final answer comes as 0 point. Then we have to place that many zeros. How many zeros will you place? You just see how many zeros are there. There are 11 zeros followed with 1 9. Now, the last question, which is 1 into 10 raised to 15. Very easy question. Here, as you see, the exponent is positive. You have to just write the number 1, okay? And you need to just place those zeros. You have to move the decimal point to the right by 15 places. So, the given number, whether it is positive or negative, we can express this in the usual form, or we can express it in the decimal notation. Okay, this is all about the exponents. So in today's session, we have recalled the laws of exponents, and also we learned to convert decimal notation to scientific notation and vice versa. Go through the videos, revise the portions, learn thoroughly. Honesty is the first chapter in the book of wisdom. Thank you, children. Have a great day.